Have you ever gazed at an artwork, such as Van Gogh's Starry Night, Da Vinci's Last Supper, or Monet's Water Lilies, and thought, there's something about them that makes them seem so pleasing, but it's not the colors or the technique the artist used? Hi, my name is David York, and today we'll be going over the golden ratio. Now, you may be wondering, just what is the golden ratio? What is its purpose? The golden ratio is a set of calculations first created by Euclid of Alexandria, a Greek mathematician, who titled it the extreme and mean ratio. Scholars use the graph of this ratio to help determine whether or not an artwork is considered aesthetically pleasing to the eye. Why use it, you may ask? Simple. The graph of the golden ratio is perfectly proportioned in a way that it creates a feeling of symmetry and balance in an artwork, therefore making it aesthetic to the eye. There are multiple ways to calculate the golden ratio, but today we'll be focusing on two different methods, Euclid's method and an applied method. This little guy is the Greek letter phi, which is a representation for the ratio. Euclid's method is simple. You take a line segment with points A, B, and C, and set it so that AC over CB equals AB over AC, which all equals phi. For segment AB, you would take it so that phi plus 1 over phi is equivalent to phi. Solving for the denominator, you get phi squared minus phi minus 1, which equals 0. Using the quadratic equation, we are given 1 plus the square root of 5 times 1/2, which is roughly equivalent to 1.618. Second method would be to take a rectangle and set the ratio so that it would be phi to x. For simplicity's sake, we'll use 1. You then divide the rectangle so you have a square with an even 1-to-1 ratio and a rectangle with a ratio of 1 to phi minus 1. From here, we can see that phi over 1 is equivalent to phi minus 1 over phi, which all solves out to the same equation we got from the previous slide. Now after all of this, you're probably asking, David, what does the golden ratio look like? Well, it looks like this. The graph looks like a spiral with a whole bunch of boxes. You might also be wondering, can I draw this without all those complicated calculations? The answer is yes, and here's how. First, you take a rectangle. Then, you divide it so you have a square on one side and a rectangle on the other side. Then, you repeat this over and over and over and over until physically you can't draw any more boxes. After this, it's pretty simple. You draw an arc that sweeps through all the squares that you made, except it looks much prettier than this, and voila! You have your very own golden ratio. Now, remember how I said scholars use this to determine if an artwork fits the ratio? Here's how you do it. They would take an artwork, such as the Vitruvian Man by Da Vinci, and simply lay the graph over it. As you can see, the proportions of this figure actually lines up with some of the ratio's squares, and even the spiral, especially at that area where the left arms connect to the torso. Another good example is the Mona Lisa, also by Da Vinci. With the right placement, you can see that her facial features all seem to reside in the innermost part of the spiral. Scholars love Da Vinci's works, as most of them, in one way or another, fit the ratio's proportions. Scholars also don't look for just proportions, but the implied flow of an artwork, and how the ratio lines up with it. Take The Great Wave by Hokusai. When you place the ratio over it, you can see that the implied flow of the wave also lines up perfectly with the curl of the spiral. In conclusion, the golden ratio is a hidden mathematical method buried deep within artworks, creating that sense of balance and symmetry that satisfies both our inner artists and our inner mathematicians. Thanks for watching. I hope you learned a great deal from this presentation.